What are the differences between physical changes and chemical changes, and how do these differences affect the properties and behaviors of substances undergoing each type of change?
Have you ever wondered why melting ice feels different from burning paper? Both are changes, but they are not the same type of change. In this video, we will learn the difference between physical changes and chemical changes, and how each one affects the properties and behavior of substances. Let's start with physical changes. A physical change is a change in shape, size, or state of a substance. But the substance itself stays the same. For example, ice melting into water, water boiling into steam, cutting paper into small pieces, breaking glass, or stretching a rubber band. In all these cases, the particles of the substance do not change their composition. Water is still water in ice, liquid, or steam. Its molecules are still H2O. So in a physical change, no new substance is formed. The change is often reversible. You can get back the original substance, like freezing water back into ice. Now let's look at chemical changes. A chemical change is a change where a new substance is formed with new properties. Examples of chemical changes include burning paper or wood, rusting of iron, baking a cake, milk going sour, vinegar reacting with baking soda to make bubbles of gas. In a chemical change, the chemical composition changes. The atoms rearrange to form new substances. For example, when iron rusts, it reacts with oxygen to form a new substance called rust, which looks and behaves differently from shiny iron. So, in a chemical change, new substances are formed. The change is usually not easily reversible. You cannot easily turn ash back into wood. Often there is a noticeable energy change, like heat, light, or gas bubbles. Let's compare physical and chemical changes side by side. New substance. Physical change. No new substance is formed. Chemical change. At least one new substance is formed. Composition. Physical. The chemical composition stays the same. Chemical. The chemical composition changes. The particles are rearranged. Reversibility. Physical. Often reversible. You can get the original substance back, like water freezing and melting again. Chemical. Usually not easily reversible, like burnt paper or a cooked egg. Energy change. Physical. Energy change is usually small or just changes state, like heating to melt or boil. Chemical. Often involves bigger energy changes, release of heat, light, sound, or gas. Observable signs. Physical. Mainly change in shape, size, or state. Chemical. Often shows color change, gas formation, smell, or a solid forming in a liquid, precipitate. Now, how do these differences affect the properties and behavior of substances? For physical changes, only physical properties like shape, size, and state change. The substance behaves the same as before. For example, melted water can still drink, freeze, boil, and react like water. For chemical changes, both physical and chemical properties change. The new substance behaves differently. For example, rust is powdery and flaky, not strong and shiny like iron. It doesn't bend like iron, and it reacts differently with other substances. Chemical changes are very important in digestion of food, photosynthesis in plants, combustion of fuels, cooking food. Let's test your understanding. You will see some changes. Try to guess, physical or chemical. Ice cream melting on a hot day.
Physical change. Still ice cream, just changing state.
Fireworks exploding in the sky.
Chemical change. New substances. Lots of light and heat.
Breaking a glass bottle.
Physical change. Same glass, just broken.
Milk turning sour.
Chemical change. New substances with a new smell and taste.
Next time you see something changing around you, ask yourself, is this just a physical change? Or is it a chemical change creating something new? Once you start noticing, you'll see physical and chemical changes happening everywhere in daily life.